describe to me what this shape is. Yeah, it's a cone and with it's a hemisphere, okay? So it's spherical, so it's a cone that's had this hemisphere sort of cut out of it. So we want to work out the volume. So how are we going to approach this question? What is essentially, just describe to me what you're going to do in terms of the way that your strategy that you use to approach this question. Any idea? How are you going to approach this question? You get this question, you think, what do I need to do? Any ideas? Okay, come on, you know something. You don't have to tell me specifics, just describe. Yeah, good, that's one thing we have to do. Find out the area of the base. Good. What else do we need to do? Edges. The areas are we looking for? Volume. Yeah, so you can find out both the volume of the cone and the volume of the sphere. When you subtract it, hemisphere, then you'll be able to work out the volume of the shape. Right, so we need to work out a couple of things. What's the radius of this circle? 9. Right, so radius of the base, trying to think about it off the top, is equal to 80 divided by 2, which is equal to 9. Okay, so R is equal to 9. What's the height of the cone? What is it? 36. Thank you. Okay, so it's 36. So now we've got the bits of information we need. What's the volume of this cone? How do we work out the volume of the cone? Somebody tell me. Right, the volume of the cone, the V is equal to? 1/3 pi r squared times h. And so it equals to 1/3 times pi times 9 squared times 36. Can you find this out? And Brooke, can you find the answer to this as well? Alright, so we're going to find what the solution is to this. Alright, so that's the volume of the cone. Now we start to be thinking about how we find the volume of this hemisphere. You get what you get? You get out of 3,000 and? Let's say this is centimeters. So we've got cubic centimeters. Okay? Now, moving along. Now the next thing we have to do is what? Hemisphere. Kelsey, how do we find the volume of a sphere? Okay? Good. So it's B is equal to 4/3 pi r cubed. And this is a hemisphere. So what do we have to do with this? Divide by 2. We're going to get half. Right, so the volume of this hemisphere, volume of the hemisphere is V is equal to 4/3 times pi times what cubed? 9 cubed. Right, so times 9 cubed. So that's the volume as if it's the whole sphere, and we have to what? Divide by 2. Okay, so we divide this by 2, and Casey, could you find out what it is? And Georgia, can you find what it is? Luke, can you find out what it is as well? And so we have grand total of 972, Casey, you got that? 972. And then the Y is divided always is verifying what we get. Where possible, let's go. 9.5 times 4 divided by 3 equals divided by 2. Oh, 1,526. Let's double check it there. That's what I got. So 1,526.81 cubic centimeters. Alright, so then to find the volume we have to subtract the volume of the hemisphere from the volume of the cone. So V is equal to 3,053.62 minus 1,526.81, and that is equal to what do we get? Something interesting happens. What do you get? Yeah, 1,526.81. What do we learn about this sphere and this cone? You subtracted the volume of the sphere, hemisphere, and you get the same result. Yeah, what is it? Yeah, the hemisphere is half the volume of this cone. That's an interesting result. It could be, whether that's true for all radii, I don't know, or whether it's just this case, but that is our solution, centimeter cubed. Alright? So again, I'll stress the fact that every one of you here knows how to do some part of these problems. Okay? Whether it's finding the area of the base, okay, whether it's simply starting off by saying what are the dimensions, what are the bits of information I need to know. Everyone knows how to find the radius. You just need to be aware that that's part of this question that you have to approach. All of you can recognize what the height is. Right? You need to recognize maybe that you need the area, so if you write that down, the area of the circle, that's part of the question. You're working out part of the solution. Right? And breaking it down into parts like that so you can get an idea. You're building up your solution, you're following through steps and reasoning that will lead you to the final answer. Right? And again, I'll say, for example, if you only got to like this point, right, if you got to this point, okay, there's some thought there showing that you're understanding part of it. We're looking at even you might if it's an assessment. Or it's showing that you're understanding parts of the problem. So don't just leave things blank. Don't say I don't get it. Try to think, break it into smaller parts. What are the shapes I know? What are the solids I can work out the volume for? Etc. Okay? So 209 is the exercise, but actually before we do that, I'm going to stop the recording. I'm going to try this. We're going to find out about this cone and sphere. That's an interesting aside, I think.